So what we're starting today is solving these rational equations. Now, one of the methods that you've got across or encountered with solving is something called cross multiplication. We multiply these two, set them equal to each other, and solve. And this works very well if we only have two fractions. Because once we start getting to these here, we can't just cross multiply because we have more than two things. We have more than one on either side, so that doesn't quite work. But what we want to look at and do with this here is factor the denominators of both terms. We want to get them as simplified as possible. That's going to be the first goal. And looking at this here, the two denominators that we have are x plus 1 and 4x plus 5. X plus 1 is as simplified as it gets. 4x plus 5 is as simplified as it gets as well. And what we want to do is multiply now by the least common denominator. Or for us here, what's going to cause both of these denominators to simplify out completely. So if we multiply through by x plus 1, let's just start there. If we multiply everything by x plus 1, the left side would be 3 times x plus 1, because we're just multiplying through. We're not doing top and bottom. We don't have to multiply the top and bottom of each side by this expression because it's equal. We're applying it to every term. And on the left-hand side, we get 3 times x plus 1 over x plus 1. On the right-hand side, we're going to multiply the x plus 1 and the 9, giving us 9 times x plus 1 over 4x plus 5. Questions on how we got to this point here? The left side, we have what? X plus 1 over x plus 1. Anything divided by itself is what? 1. So these two here will simplify. Do we have a fraction on the left-hand side? No, because it reduced out, it simplified out, yes? So we can look to the right. 9 times x plus 1 over 4x plus 5. Will anything simplify on that side? Well, no, because the x plus 1 and 4x plus 5 are different. We don't have something in common on top and bottom. What would we need on top of that second fraction to get to reduce? 4x plus 5, because if we had 4x plus 5 here, then we would have something in common on top and bottom that's being multiplied, yes? And those two would cancel out. But we can't just multiply one side of the equation by it. We've got to multiply both. Which means we're multiplying the left and right side also by 4x plus 5. Which is also telling me that that least common denominator for this equation is 4x plus 5 times x plus 1. Questions on how we got here? Now let's see what's left. On the left-hand side, we still have the 3 and the 4x plus 5. On the right-hand side, what we're left with is 9 and x plus 1. Questions on this here? We good with this so far? If we had done the cross multiplication, let me get a highlighter, we would have been multiplying what? 3 and 4x plus 5. Well, what do we have to multiply right now? 3 and 4x plus 5. Our other cross would have been 9 and x plus 1, which is what we have, yes? This here, what we just did, multiplying by that least common denominator, is what we're doing in cross multiplying. It is the reason it works. But using the least common denominator to multiply through works with any equation. No matter what the setup, no matter what the start, no matter how many terms we have, multiplying by that least common denominator will always work. Cross multiplying will work as long as I have one fraction on either side of the equal sign. We kind of see the difference between the two. Personally, I would rather learn the method that works for all first, not the method that works as long as we have 1 and 1. Because at this point here, we just need to solve for x. Because once we get rid of the fractions, we're going to solve for x. So on the left-hand side, first thing we need to do is distribute the 3. 3 times 4x is 12x. 3 times 5 is plus 15. On the right-hand side, 9 times x is 9x. 9 times 1 is plus 9. Now we need to get x by its self. So what can we do first? Because really there's 4 different things that we could do. We just have to pick one of them. We can subtract 9x. Now, sometimes at this point, it's trying to figure out what we do first, but it really doesn't make a big difference because subtracting 9x is one of the steps we can do. Now, again, I said there's 4. We could have also subtracted 12x from both sides. Or we could subtract 9 from both sides, not 9x, the other 9. Or we could subtract 15. We just have to pick one of them to do first. Because when we subtract 9 from both sides, 12x minus 9x is 3x plus 15 equals our 9x minus 9x simplified to 0. They cancel each other out, leaving us with 9. Now again, the goal is to get x by itself. And we always want to do addition and subtraction first before we do multiplication and division to move terms from one side to the other. So what would we want to move next? Well, the 15, because the x's are already together. And since 15 is positive, we want to do the opposite operation. Instead of it being positive, we want negative, so we will subtract. Because 15 minus 15 is 0. Leaving the only term on the left-hand side to be 3x. 9 minus 15 is? Negative 6. Do you have anything left addition and subtraction wise on either side? Nope, all the x's are on one side, so now we're going to move to multiplication division. And the last thing we need to do is divide both sides by 3. And negative 6 divided by 3 is negative 2. So we have that the value of x, the solution is negative 2. Questions on this first one? Question on anything we've done so far? Now we can check and make sure that this is correct. And to check it, all we need to do is plug it back in. We need to plug that value of x back in every x and make sure both sides are the same. So, all right, guys, focus in. So when we check this here, we replace each x in the equation with negative 2. Now at this point here, we can check this by hand or we can plug it into the calculator. Either one works. Because if we check the left side by hand, 3 on top is going to stay. On bottom, we have -2 plus 1, which would be -1. And 3 divided by -1 is -3. So it's telling us that the left hand, the left side of the equation, when we plug -2 in for x, we get a value of -3. On the right side, 4 times -2 would be -8. -8 plus 5 is going to be -3. And 9 divided by -3 is -3. So both sides do have the same value. They are equal, telling us that -2 is a solution. -2 is a value of x that will work for this here. Questions on this here? Questions on any of this so far? Now, there are 2 values of x that would not work for this here. Because no matter what the setup or how it's solved, we already know what the value of x is. But there are restrictions on what x cannot be. Now, we've talked about these before. We talked about them with addition, subtraction, our simplifying, our restrictions. And our restrictions are any value of x that will make one of the denominators be 0. Because if we get a value of x that makes the denominator 0, it is a restriction, it's an extraneous solution. It's a value of x that we get from solving that does not work in the original context, that does not work in the original problem. So for x plus 1, we minus 1 from both sides, telling me that if x is -1, we would get a denominator of 0. It does not work. We cannot have that as a value of x. So x cannot be -1. We can do the exact same thing for 4x plus 5. We subtract 5 from both sides, telling us that 4x is equal to -5. Divide both sides by 4, telling me that if x is equal to -5/4, we would have a division of 0. We cannot have a division of 0. We can't divide by 0. So -5/4 is one of our restrictions. Now, neither one of these came up as a solution, but if they did, we know that x cannot be those values. It's not going to work. And this is nice, especially when we start solving some of the bigger equations, bigger problems, where I'm not even going to have to plug them back in. It's going to tell me if it's a restriction, it does not work. I don't have to plug it back in. I don't have to check it. I know immediately it does not work. That's the nice thing with restrictions. So let's look at this second problem. We have 2 over x plus 2 is equal to 10 over 3x plus 2. Now, if we find our restrictions, it's any place that's going to give us a division of 0. Now, luckily, since we're just dealing with an equation, fractions, we don't have multiplication, division, specifically division. It's just whatever is going to make the bottom of the fraction be 0. And when we find these restrictions, it is helpful to factor them down first so that we're not finding multiple zeros. It's going to make it a little bit easier to work with. Now, with our x plus 2, we subtract 2 from both sides. 2 minus 2 is 0, leaving us with x, telling us that if x is equal to -2, we get a division of 0. Does not work. Also tells us that if we get a solution x equals -2 for this problem, it is not a solution. We have to throw it out. With our 3x plus 2, we can subtract 2 from both sides. And our 3x plus 2 is going to become 3x. 0 minus 2 is -2. Still need to get x by itself, so we would divide both sides by 3, telling us that if x is equal to -2/3, we'd have a division of 0. That does not work. So for this here, we need to find a value of x that will make these be true. and we know for certain if it's -2 or -2/3, those solutions will not work. We can throw them out. Questions on this so far? So, solving this here, 2 over x plus 2 is equal to 10 over 3x plus 2. Just like the first one, it's going to be very nice to get the fractions to simplify out. Because if I don't have to work with fractions, especially with solving, it's going to make the problem nicer to solve. What do I need to multiply the left-hand side by to get 2 over x plus 2 to simplify? X plus 2, because if I multiply this left side by x plus 2, we would get 2 times x plus 2, because it's multiplying on top, over x plus 2. And that x plus 2 and x plus 2 would simplify because we do have multiplication on top, single term on bottom. And if we do it to one term or one part of the equation, we have to do it to the rest, all of it. So that takes care of the fraction on the left-hand side, yes? Let's look at the right. Well, multiplying that by x plus 2 get that fraction to reduce. Well, no, because the denominator, the bottom of it, is not x plus 2. It's what? 3x plus 2. So we'd actually need to multiply it by 3x plus 2. Because we get that the n times 3x plus 2 times our x plus 2, because we have to multiply both, and it, that 3x plus 2 and the 3x plus 2 on bottom would cancel. And again, if we do it to one side, we have to do it to the other. So we have to add that to the other side. So really what we needed to multiply everything by is x plus 2 and 3x plus 2. Now on the left-hand side, the x plus 2 and x plus 2 are going to cancel, leaving us with 2 times 3x plus 2. On the right-hand side, the 3x plus 2 and 3x plus 2 will cancel, giving us 10 times x plus 2. So the big thing I'm doing here in trying to get us to be able to solve, or our steps in solving, is looking at both of the fractions, or looking at all the fractions, seeing what do I need to multiply it by to get that denominator to go away, and seeing if I need anything else. Any questions on any of this here so far, how we got to this point? Now we just need to solve for x. So on the left-hand side, we can distribute 2. 2 times 3x is 6x. 2 times 2 is 4. On the right-hand side, we're going to distribute the 10. 10 times x is 10x. 10 times 2 is plus 20. Now that we've resolved the parentheses, what can we do next? We can if they're on the same side. But unfortunately, the equal sign in the middle kind of prevents us from just combining. So we will need to use our, I think Ms. Williams calls it diva steps. We need to move our terms, like terms, onto the same side. We can minus what? 4. We can minus 4 from both sides. I need to move the numbers without x onto one side, and I need to move the numbers with x onto the other. So our 4 minus 4 will give us 0, leaving us with 6x on the left-hand side. On the right-hand side, we'll still have the 10x, but 20 minus 4 is going to be plus 16. Still need to get the x's on the same side, so at this point here we would do what? Because we wouldn't divide quite yet, because we need to move the x's over. We can, it would just make things a little more complicated. Because I want to get the 10x over to the other side first before we divide. Because on the right-hand side, 10x minus 10x would be 0, leaving us with just 16. On the left-hand side, 6x minus 10x, 6 minus 10, would be negative 4x. Now we would divide. Because once we get all the variables that we want on one side, number on the other, we can divide by the number in front of the variable. In this case, would be dividing by negative 4. 16 divided by negative 4, positive divided by negative is going to be negative. 16 divided by 4 is 4. Telling us that x is equal to negative 4. Is that one of our restrictions? No, so we know that should work. That should be our solution. If we wanted to check, we could replace x with negative 4. And we could do this on a calculator. We could say 2 over negative 4 plus 2 and 10 over 3 times negative 4 plus 2. 2 over negative 4 plus 2 is negative 1. The other side, 10 over 3 times negative 4 plus 2 is also negative 1. Almost. Got the right page now. So when we plug it in, it's really telling me that negative 1 is equal to negative 1. It works. That is the correct answer. So what we're really trying to find is the value of x. You don't need to do it unless it's specifically asked, because there are going to be a few problems on the test that do ask you to check your answers. And on those parts, for checking, almost got it. This is everything I'm looking for the check step, showing that you did plug it back in, and it did give the same result. Yes? So if they equal each other, because then it would just, that solution's thrown out. It does not work, it's a no solution. Or, because it won't work most likely, especially on these here, the ones that won't work are going to give you a domain error, division of 0 error, because those bottoms aren't going to be the same. If not, especially on the homework, you keep getting different things asked. We'll look back at it. Yes. Questions on any of this here? Let's look at the next one. 3 over 5x is equal to 2 over x minus 7. If I want to find the restrictions, I want to find the values of x that are going to make the denominator be what? 0. And there's two places. One of them is 5x and the other is x minus 7. So if I want to solve the 5x one, the first thing we would do is divide both sides by 5. Well, 5x divided by 5 would be x. 0 divided by 5 is 0. So x cannot be 0. We also need to see what's going to make x minus 7 be 0. Add 7 to both sides. And if x is 7, we would get a division of 0, because 7 minus 7 is indeed 0. I'm going to rewrite it so I have a little more space. So what do we know that we need to multiply each thing by to get those fractions to go away? Or what's one thing we know we need? What do we need to multiply everything by? What's our denominators? 5x and x minus 7, because we want the denominators to go away. We want them to simplify out. Now from here, we can rewrite this again as 3 times 5x times x minus 7 over 5x. But we know on the left-hand side, the 5x and 5x will cancel. So is there anything saying I couldn't just go here and here at the start when we do the multiplication through? No. I do this step here. I do this step here to show why it works. Because when we multiply with the top, giving us 5x over 5x. 5x divided by 5x is 1. It simplifies out. On the right-hand side, we would, when we multiply, get 2 times 5x times x minus 7 over x minus 7. The x minus 7 and x minus 7 would indeed cancel. But just like the left-hand side, we could have just gone here and here. So let's see what's left. We have 3 times x minus 7 is equal to 2 times 5x. Questions? 3 times x is 3x. 3 times negative 7 is negative 21. Right-hand side, 2 times 5x is 10x. Now, there's a little bit less options for this one here because we only have 3 terms to move, yes? Are the x terms, the terms with x on the same side? No, they're on opposite sides. Are our constant terms, the terms without x, on the same side? Well, yes. So we could, if we wanted to, add 21 to both sides. But is that helping us get the constant terms by themselves? No, they're already by themselves, yes? So what I would do is move the x over by subtracting 3x. Because on the left-hand side, 3x minus 3x is 0. Bless you. Leaving us with negative 21 is equal to, yes, 7x. Now we have the variables by themselves, numbers without variables by themselves, so we can divide both sides by 7. 7x divided by 7 is negative 21 divided by 7 is negative. Does it matter that I flip the side with x and negative 3? No, equality works either way. Is that one of our restrictions? No. So we should, since it's not a restriction, if we plugged it back in, it will make both sides be the same. Questions on this here? So that's the big thing this is hinging on again. Least common denominator, factoring those and multiplying through. We will stop here. We will finish this tomorrow. Yes.